Hello, welcome to lecture 2. This is 1.3, and we are talking about real numbers. So we're going to add and subtract real numbers, which in this lesson, we're going to call combining real numbers. We're going to multiply and divide them, and then we are going to simplify expressions containing exponents. The inverse of an exponent is a root. So we'll work with a little bit with roots. We're going to use the order of operations, and then at the very end, evaluate, I think, 2 algebraic expressions. Okay. So real numbers just mean positive and negative. Well, I think we went over it last lesson, actually. A real number is a positive or a negative number between negative infinity and infinity. So it can be anything, any number that you can imagine on the number line. Okay. So when we're to add 2 real numbers with the same sign, so if they have the same sign, add the absolute values and keep the common sign. Remember, we talked about absolute values. When you see absolute value, think distance, right? So whatever is inside these absolute value bars, we want to know how far is it from 0. So it can never be a negative distance from 0, right? So this is just addition and subtraction, right? If we look at it, this is addition and subtraction. However, just to practice today, we want to look at it as combining. And so if they have the same sign, we add them and keep the common sign, okay? Add the absolute value and keep the common sign. If we are combining, so that's not even, add is confusing here, right? To combine, two numbers with different signs. So if they have different signs, we want to subtract the smaller one and keep the sign of the larger number. Okay, so it sounds more confusing than adding and subtracting, right? But we're going to practice it today. You are always welcome to use your calculator, but this is to explain how the calculator got the answer. Math is all about applying critical thinking skills, right? So do you understand the rules why -14 plus -9 equals -23, right? Can you go into a situation, analyze it, decide what rule to use, and then apply that rule, right? So these are just rules for combining real numbers rather than just the addition and subtraction that we have, that's more common to us, right? So again, instead of add, we'll say combine. So here we are combining a -14 and a -9. So those are 2 numbers with the same sign. They both have a negative sign. So what we want to do is add them and keep their common sign. And when you're adding them, you're ignoring the negative signs because we're adding the absolute values. How far is -14 from 0? It's 14. How far is 9 from 0? It's 9. And we're going to combine those. So we're going to add 14 and 9. We get 23, add the absolute values, and then keep the common sign. The common sign, oh, I'm sorry. The common sign, so 14 and 9 is 23. The common sign is that they were both negative, okay? -11 and +18, now we have different signs. So we take the absolute value. The absolute value of -11 is 11. The absolute value of 18 is 18. Subtract the smaller absolute value from the larger absolute value. So 18 minus 11, right? 18 minus 11 is 7. And then it says, keep the sign of the number with the larger absolute value. Which one of these has a larger absolute value, 11 or 18? 18. The sign with 18 was a positive, so the answer is a +7. 8 and negative 13 we are combining. Those have different signs. So the absolute value of 8 is 8 because 8 is 8 units from 0. Negative 13 is 13 units from 0. So we're going to subtract the smaller absolute value from the larger absolute value. We get 5, right? Keep the sign of the number with the larger absolute value. So 13 is larger than 8. 13 had a negative sign, so 5 gets a negative sign. All right, let's keep practicing. Next we have, oh, actually, why don't you pause the video and then try this. Try A, B, C, and D on your own. So pause me, do it, and then watch me, see if I get the same answer. All right. Okay, so we have two different signs. So we're going to take the absolute value is 21 and 12. We're going to subtract them, right? The absolute value of negative 21 is 21. The absolute value of 12 is 12. The signs are different, so we're going to subtract them. 21 minus 12 is 9. And then we want the sign of the larger absolute value, which is 21. So it's going to be a negative 9. It's a negative 9 because the 21 is a negative. It's 9 because 21 minus 12 is 9. We chose that because the signs are different. Ooh, all the signs are different. So again, we have a 22 and a negative 9. Those are different signs. So the absolute value of 22 is 22. The absolute value of negative 9 is 9. We're going to subtract them. 22 minus 9 is 13. The sign of the bigger number is a positive, so it's going to be a positive 13. Good. So this is because the sign of 21 is a negative sign. This is because the sign of 22 is positive. Okay. Here we have 0 plus a negative 12. 0 is neither positive or negative. So 12 minus 0 is 12, right? And then the 12 is the greater distance from 0, and it's a negative, so it's a negative 12. Or you can just say negative 12 plus nothing is negative 12. All right. Letter D, we have two different signs that we're going to apply the same rule. We applied to A, B, and C to D. However, before we apply that rule, we need to incorporate the rules of fractions. And the rule of fractions for adding or subtracting fractions is that we need a common denominator. So a fraction, the top number is called the numerator. The bottom number is called the denominator. If you're going to multiply them, we could multiply them straight across. But because we're adding them, we can't add. So if I have here, so one is 4/5, right? So I'm going to take this and divide it into 5. 1, 2, 3, 1, 2, 3, 4, 5. Whew. And then I'll divide this one into thirds, right? I can't combine 4/5 and 2/3, right? But if I have a common denominator, I can combine them very easily, okay? So what number can I continue breaking these pieces into? How many pieces can I break it into until they're all the same amount of pieces, okay? 4/5, 2/3, 5 and 3, probably 15, right? 15 is the number, the smallest number that both 5 and 3 go into evenly, okay? So now I want to say, so what I want is I want this to be over 15, and I want this to be over 15. Because 1, 2, 3. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. One more, 15. That was terrible. So oh my goodness. If each of these now has 15, we can combine them easily, right? 13, 14, 15. Very bad visual aid. But now they're combinable, right? Because now they're out of 15 and out of 15. Instead of before, they were out of 5. And here we were out of 3, right? We couldn't combine out of 5 and out of 3. But now that they're both out of 15, we can combine them. So what did I have to multiply -4/5 by to get the 5 to be a 15? What did I have to multiply 2/3 by to get the 3 to be a 15? Here, what times 5 is 15? 3. Anything I do to the bottom, I have to do to the top because fraction. So here are things we know about fractions, right? If I want to make something a fraction, I can just divide it by 1 because it is itself. Here we have 4/5, right? If I take the top and I multiply it by 5 and I take the bottom and multiply it by 5. Oops, sorry. 4 times 5 divided by 5 times 5. 0.8 is the same as 4 divided by 5. So I can multiply the top and the bottom by anything, and I'm not changing the amount of the fraction. I'm just making it, see, it's still that same amount. I'm just making it easier to combine it over here. So here we're going to multiply them both by 5. Okay. So what we get is 4 times 3 is 12, right? -12. And then here we get 15. Plus 2 times 5 is 10. 3 times 5 is 15. I'm sorry, that negative was more in the middle. -12/15 is the same as -12/15. So you can put it on the top or on the bottom or in the middle. All right, now that they are both over 15, we can add them, we can combine them. The bottom stays 15, and now I have -12 pieces here, and I have 10 pieces here. -12 and 10 makes -2, right? Because they are different signs. So we took the absolute value and subtracted. 12 minus 10 is 2, and then the sign, the 12 was a negative. So it's -2/15. All right, example 3. Here we want to combine a +6 and a -10. They are different signs. So we're going to say this is the absolute value is 6. Here the absolute value is 10. 10 minus 6 is a +4. The sign of the bigger absolute value is a negative sign. So it's -4. Good. Over here we have 6.9 plus 1, or sorry, 6.9 minus a -1.8. Anytime you have 2 negative signs in a row, it is the same as adding them. So you just want to turn that into a big plus sign. (6.9) plus 1.8. How do we add fractions? We line up the decimal. So 6.9, 1.8. 9 plus 8 is 17. I'll carry the 1. 6 plus 1 is 7, plus 1 is 8. Bring that decimal down. 8.7 is our answer. And they were both positive after we changed the double negative to a positive. So it's a +8.7. -14 and -19 Those are the same sign. So we just add 14 and 19. We get we get 33. And because both of them are negative, it's a negative 33. All right, here we have a typo. What I really wanted to say was negative 3/4 plus negative 4/5. Okay, and this will be just like this top one. We have 3 out of 4 and 4 out of 5. So let's do the wheel again, because I didn't really make it clear that we weren't using the entire. This is one whole, right? Each wheel is one whole. This wheel is going to get divided into 4. This wheel is going to get divided into 5. Okay, but we only want 3 out of 4. And here we only want 4 out of the 5. But I can't put those together very easily, right? So if I can change the 4 and the 5 to something they both have in common, what would that be? What's the smallest number both 4 and 5 go into evenly? It is 20, right? Because 4 times 5 is 20. So that means I need to multiply this side to get 20. I need to multiply the 4 by 5. So on top, I'm going to multiply by 5. Over here, to get the 5 to be a 20, I need to multiply it by 4. Here, I'm going to multiply it by 4 on top as well. Okay, so now 4 times 5 is 20. 3 times 5 is 15. And remember, this is a negative. Plus 4 times 4 is 16. 5 times 4 is 20, also a negative. Okay, so 15 and 16, they have the same sign. They're both a negative. The 20 stays the same. They both have a negative sign, so they're in common. 15 plus 16 is 31. And they're both negative, so it's a negative 31 over 20. Good. So instead of this having 5 pieces, it will now have 20 pieces, right? All right, it has 20 pieces, but we're only taking 15 of them and we're leaving 5. Okay, here, this now has 20 pieces. We're only taking 16 and we're leaving 4. Okay. Sorry, we're leaving 5 here, we're leaving 4 here. Ooh. Good, now they are even. All right, and 12 minus a negative 16. Again, the negative becomes a plus. The double negative becomes a plus. We have a 12 and we have a 6. The 12 is, sorry, the signs are different, and so we're going to subtract. 12 minus 6 is 6. And then the 12 has the bigger sign, and it was, or sorry, the 12 has the bigger absolute value, and it was a negative absolute value, so it's a negative 6. Hold on a second. I thought I skipped a page because my first page was not double-sided, and then my second page is double-sided, so I thought I skipped a page. Example 4, we're simplifying. It's the same thing as example 3. However, we're combining only two at a time. There are 3 total here, but we're only going to do 2 at a time. Go from left to right, okay? So here we have 12 minus 5 minus 7. Just look at the 12 minus 5. Those are 2 different signs. It's a positive 12 and a negative 5, right? So if they're different, we're going to subtract them. 12 minus 5 is 7. They keep the sign of the bigger absolute value, which is 12. So it's a positive 7. And then we're going to bring down the 7. So 7 minus 7, that's a positive 7 and a negative 7. So we're going to subtract them. So we get 0. Good. Here we have 9 minus 6 minus a negative 3 plus 8. We see that? We go like that, right? So it becomes 9 minus 6 plus 3 plus 8. 9 minus 6, those are different signs. We have a 9 and a 6 as the absolute value with different signs. So we're going to subtract. So we get a 3. The 9 is the bigger of the 2 absolute values. So we keep the 3 positive because the 9 was positive. Now we're going to bring down the plus 3. 3 plus 3 is 2 positives. So that's combined together. We get 6 plus 8. I should probably put the plus 8 here too, just to be clear. 6 and 8, they're both positive. So we combine the absolute values and we get a 14. They were both positive, so the 14 is a positive. Good. All right, so as I write this, I'm going to carry it along. Makes it more clear. Negative 9 minus 5. So those absolute values are 9 and 5. We're going to combine them because it's the same sign. So we get a 14. It's a negative 14 because they both are negatives. Plus 11 minus a negative 7. Negative 14 plus 11. So it's a negative 14 and a positive 11. 14 and 11. Sorry, they're different signs. So we're going to subtract. 14 minus 11 is a 3. It's going to take the sign of the bigger absolute value. That's the 14. So it's a negative 3 minus negative 7. And again, we see that. We make it into a plus. Negative 3 plus what is now a positive 7. So negative 3, positive 7. The absolute values are 3 and 7. We want to subtract them because they have different signs. 7 minus 3 is 4. And then it keeps the sign of the 7 because 7 is the bigger absolute value and it is positive. All right, now we're going to multiply real numbers. The product of 2 numbers with the same sign is a positive number. So what we're saying is, if the signs are the same, it will be a positive. The answer is always positive. Here, if the signs are different, the answer is negative. Is always negative. Product property of 0, anything multiplied by 0 will equal 0. All right, example 5, multiply negative 3 and positive 8. That is an understood positive. This is a negative. If the signs are different, it will always be negative. And then 3 times 8 is 24. Negative 5 and negative 2, if the signs are the same, it will be positive. The 5 times 2 is 10. 0 times negative 50 is 0. 10 times negative 5, because if it's right next to each other with parentheses, it always means multiply. So 10 times 5 is 50, and those signs are different. If the signs are different, it's always negative. We have negative 24, 10, 0, and negative 50. For multiplying fractions, it is not the same as adding and subtracting fractions, so we go straight across. Okay, we have a negative 5/6 times 1/4. 5 times 1/6 times 4. And 1 is a negative, so we'll make it negative. Negative 5 times 1 is 5. 6 times 4 is 24, sorry. (5/24), and it's a negative because one of them was negative, one was positive, so they're different signs, so it's negative 5/24. All right, why don't you pause it again and see what you get for the next 3 examples. Try the next 3 examples without me. Again, multiplying from left to right, one set at a time. 5 times 0 is 0. 0 times -3 is 0. 6 times -2.3. That will be a negative answer, right? Because because they have different signs. One is a negative, one is a positive. How do we multiply fractions? 2.3 times 6. You multiply it as though there were no fractions. So 6 times 3 is 18. I'm going to put a 1 right here. 6 times 2 is 12. Add that once, we get 13 here. And then you just count how many numbers were behind the decimal and give the answer the equal amount of numbers behind the decimal. So it's 13.8 is our answer. And because we have 1 positive and 1 negative, it's a negative 13.8. Here we're multiplying -1 times -6. Those are 2 negatives. 1 times 6 is 6. 6 times a -7 is 42. And because we have 1 positive and 1 negative, we get a negative. So 3 negatives make a negative. 2 negatives make a positive. 3 negatives make a negative. Right, dividing real numbers, it's the same. If the 2 numbers have the same sign, it's going to be a positive answer. If the 2 numbers have different signs, it's going to be a negative answer. Okay. So remember, the fraction bar is just a division symbol. You can just as easily write this as 42 divided by -7. And 42 divided by -7 is 6. The 2 signs are different, so it's going to be a -6. -16 times -12, it's going to be a positive answer because their signs are the same. 16 divided by 2 is 8 because 8 times 2 is 16. -80 divided by 10. 10 goes into 88 times, and they have different signs, so it's a -8. Ooh, and then we are dividing with 0. All right, here are the rules here's the rule for dividing with 0. If the 0 is on top, it's okay. If the 0 is on bottom, it is not okay. There are 2 rules of things you cannot do in math. You cannot divide by 0. No 0 in the denominator of a fraction. No dividing by 0. And you cannot have an even, or sorry, take the even root of a negative number, which we will talk about later. Take the even root of a negative number. So the root is this. We'll get to it in a minute. That's the square root. So what that means is there's a little 2 up there. So the square root of 16 is 4, right? It's the most common one. So if you don't put any number here, we assume it's a 2 because 2 is the most common. You can also take cubed roots, 4th roots, 5th roots, 6th roots. So if the root you're taking is even, like 2, you cannot take it of a negative number. You could do the 3rd root of negative 16, but you cannot do, oh, sorry. I meant to do that one. You can't do the cubed root of negative 16. You can do the cubed root of negative 16. You cannot do the square root of negative 16. Non-real answer. You also cannot divide by 0. Okay. 0, that's a 3, not a 0. 0 divided by negative 7 will be 0. Negative 7 divided by 0 will be a non-real answer. You cannot do it. So 0, think about it. We're taking 0 and we're dividing it into 7. So we have 7 here. And we're taking nothing and putting it into groups of 7. How many groups of 7 did we make? We made 0 groups of 7. Okay. But here we have 8 things to put into a group, but we have no groups to put it in. So we can't just say 8 into 0 groups is 0. 8 into 0 groups, we can't. Is indefinable. You cannot define it mathematically. We're on example 8. So let's practice dividing. Remember, with dividing, you can just go straight. No, sorry, we cannot go straight across. With multiplying, we can go straight across. With dividing, we have to keep, flip, change, KFC. Stands for keep the first fraction the same, flip the second fraction, change the sign. To multiplication. So keep the first fraction, flip the second fraction. And then change the middle sign from a division sign to a multiplication sign. Let's practice. So we'll K negative 5/9. We'll F 2/3. So it becomes 3/2. And then we will change the division to a multiplication symbol and see what we get. Now we can just go straight across. So now it's negative 5 times 3 on the top, 9 times 2 on the bottom. Okay. And if you want to, you can right now try to simplify. So can I divide any of this on top by the bottom? So back here, 1 second. Back here, we said it's okay to multiply 2 times 5 and 3 times 5. It doesn't change the 2/3, right? 2 times 5 is 10. 3 times 5 is 15, right? So 10 divided by 15 is 0.6. 2 divided by 3 is also 0.6. So you can multiply the top and the bottom by any number you want. It will keep the fraction's value the same. In that same way, you can divide the top and bottom by whatever number you want, and it will keep the fraction the same. So you could multiply this, get your answer, or you could simplify it and say I can divide 3 by 3 and I can divide 9 by 3. If I divide 9 by 3, I get 3. If I divide 3 by 3, I get 1. Now I have 5 times 1 over 3 times 2, which is 5/6. Or you can just go 5 times 3 is 15. 9 times 2 is 18. And then 15 and 18 both go into 3, right? And 15 goes into 3 5 times. 18 goes into 3 6 times. Oops. 15 over 18 is 5/6. Simplest form. But they equal the same thing, right? 15 divided by 18, 5 divided by 6. It's just simplest form. All right, now we have a negative divided by a negative. We're going to KFC it. So first we're going to keep -2 over 7. We're going to flip -1/5 to 5 over 1, which is just the number 5. And then we're going to multiply those two together. So here we get -2. Oh, did I keep the negative? I never keep the negative. I forget. Sorry, both of those. I lost the negative. Negative, negative. So it's -5/6, -5/6. Which reminds me, you could be checking this on your calculator. So we have 5/9. I'll say -5/9 divided by 2/3. -5/6. Whew. All right, so we have -2 over 7. Sorry, -2 times -5 over 7 times 1. So I just put the negative up with a 5 because I had to decide because we're putting it all together. So I'll put the negative up with a 2 as well. So 7 times 1 is just 7. -2 times the -5 is a 10. They have the same sign, so they're positive, right? So it's 10/7. Now, exponents. Exponents that are natural numbers are shorthand notation for repeating factors. Repeating factors just means exponents are a shortcut of multiplication. They tell us how many times, the exponent tells us how many times to multiply the base by itself. So here we have 3 to the power of 4. 3 is the base. 4 is the exponent. And as you can see, it's the 4 tells us that we need 4 3s. 3s tell us what number to make the 4 numbers. So 3 times 3 times 3 times 3. 81. 3 to the 4th power, 81. Exponents are calculated before you multiply or divide. All right, so we just said 3 to the 4th power is 81. -5 squared, -6 squared. Do you see the difference between these two? Here, because of the parentheses, the 2 is asking us to multiply the -5 times itself. But here, because there's no parentheses, it's just saying it's a negative of 6 times 6. So here the 2, the exponent only applied to the closest term. Here the exponent applied to everything in the parentheses. So -5 times -5 is 25, whereas -6 times 6 is -6. 36. See the difference? -6 squared, -5 squared. So with or without the parentheses is the difference. All right, we have 2/3 to the 3rd power. Which is 2/3 times 2/3 times 2/3. Good. 2 times 2 is 4. 3 times 3 is 9. 4 times 2 is 8. 9 times 3 is 27. Sorry. Ugly. 8/27. Two-thirds to the 3rd, 8/27. All right, the inverse of, so these are called exponents. The inverse of an exponent is the square root. The square root, as we talked about, there's always like a little 2 here, but because you can take any root of a number. You could take the 3rd or cubed root, you could take the 4th root, you could take the 5th root, and we'll talk about that later in the class. But if there's no number here, it's the square root, the 2nd root of a number. So 3 to the 4th. Let's see. 3, if I did this to 3 to the 4th, I would get 3. So we have good. They undo each other. So the square root of 8 squared is 8. So if you know 3 squared is 9, the square root of 9 will be 3. Good, because 3 times 3 is 9. In order to find a square root of this number, you need to find the number that when it is multiplied by itself, it equals that number. So the square root of 16 is 4 because 4 squared is 16. Or 4 times 4 is 16. The square root of 1/36, you can treat that as 2 different square roots, square root of 1 over the square root of 36. The square root of 1 is actually 1, because 1 squared is 1. 1 times 1 is 1. And then the square root of 36 is 6, right? 6 times 6 is 36. Cubed root means now I need a number that I multiply by itself 3 times. So if I had 2 times 2 times 2, that is the same as saying 2 to the 3rd power. Good. And 3 to the 3rd power, or 3 times 3 times 3, is 27. So the cubed root of 27 is 3. The 4th root of 16, if this is 8, what do you think that is? Yes, it's 8 times 2, which is 16. So the 4th root of 16 is 2. Order of operations is PEMDAS, or I have also seen it as this, because the G stands for grouping symbols. Just like the parentheses stands for all grouping symbols. So perform all operations in parentheses first. If there are more than one set of grouping symbols, start inside and work your way out. Okay. Some other grouping symbols include, we have parentheses, we have brackets, we have braces. we have even the fraction bar, because if I put two terms up here or two terms down here, I have to do those terms before I divide them. So the fraction bar can be a grouping symbol. The root symbol can also be a grouping symbol because I can put more than one thing under here. And the absolute value bar can be a grouping symbol. So this is whatever my group is. And then those are different. So you always do these before anything else. Then we'll do exponents. And then we will multiply and divide, or divide and multiply. It does not matter the order, just whichever you see first from left to right, and then adding and subtracting from left to right. Okay. All right, so let's simplify. We have we need to remember PEMDAS, so we're not just going from left to right now. We're going to do exponents first because we have division, addition, and exponent. So 5 squared is 25, right? Everything else stays the same. Now I have 6 divided by 3 plus 25. I'm going to do the division before the addition. 6 divided by 3 is 2 plus 25. So I'm going to get 27. All right, here we have addition, parentheses, and an exponent. We need to do the parentheses before the exponent. So we say 2 plus 5 negative 4 times negative 4 squared. Now I'm going to take that negative 4 and square it. So it's 2 plus 5 times 16. I'm going to multiply before I add. 16 times 5 is 80. Plus 2 is 82. Again, this is a grouping symbol, so we're going to do everything on the top and everything on the bottom separately. 3 squared is 9. I'm going to do the division before the addition. 9 divided by 3 is 3, so 6 plus 3 is 9 over 9, and anything divided by itself is just 1. All right, and when you have many grouping symbols, you want to start with the innermost grouping symbol. So here we have parentheses, but we have 2 sets of parentheses. So we want to start with the inside parentheses. So here it will be 1 plus 2, 5 times 2 times 3 is 6 plus 1 minus 10. Close the parentheses. 1 plus 2. The next thing is 6 plus 1 times 5 times 7 minus 10. 1 plus 2. I'm going to multiply before I subtract. 5 times 7 is 35 minus 10. Now I'm going to do what's in the parentheses. 1 plus 2 times 35 minus 10 is 25. 2 times 25 is 50. 1 plus 50 is 51. Good. All right. So here we have negative 5 times the square root of 30 minus 5. So here's an example of it being a grouping symbol because we put 2 numbers under that radical, plus negative 2 squared divided by 4 squared plus the absolute value of 7 minus 10. So here I have negative 5 times the square root of 30 minus 5 is 25, right? Plus negative 2 squared all over 4 squared plus 7 minus 10 is a -3. Good. I'll then move this up here. -5 times the square root of 25 plus -2 squared is 4 over 4 squared is 16 plus, and I'm going to take it out of the absolute value bar now, 3. Good. Now I have -5 times the square root of 25. -5 times, 5 plus 4 over 16 plus 3. -5 times 5 is a -25 plus 4 over 16 plus 3. -25 plus 4 is a -21. And then 16 plus 3 is 19. So we have -21 over 19. All right, on our last one, ignore because I did not write any equation. But basically we're substituting 9 in when we see x and -4 in when we see y. So we have -3 times -4 squared. The first thing I'm going to, so I'm going to multiplying and I have an exponent. The first thing I'm going to do is the exponent. So -3, -4 squared is 16. -3 times 16 is -48. Good. All right, I'm going to do this one on a blank sheet of paper, so I have plenty of room. I tried doing it and I ran out of room. All right, the square root of, so we're going to take the square root of x over y plus y over x. All the x's are 9s, all the y's are -4. So this should now look like the square root of a +9 over a -4 plus a -4 over 9. The first thing I want to do, so it's adding, so I need like terms on the bottom again, right? The first thing I want to do is take that 9 out of the radical, because if I'm going to have to multiply the -4 and the 9 by something, I don't want to be multiplying by something that's still under a radical. So I'm going to take it out. So I know the square root of 9 is 3, and that's a -4 plus -4 over 9. The next thing I'm going to do is I'm going to take these negatives and just put them out in front so that it doesn't get too confusing. So it's a -3/4 plus a -4/9. So now I should be able to see that with these two negatives that I'm adding, that if I'm adding two negatives, I should end up with a negative, right? Okay, they are the same term, so I'm going to combine them together and give them a negative at the end. All right, so again, we have, I'm going to rewrite it. We have -3/4 plus -4/9. So what we've been doing today is finding a common denominator by saying, what can both 4 and 9 go into evenly, right? And we decide, oh, I'll just multiply this by that and that by this, essentially, right? And I'm going to ignore the negative sign. The negative sign goes with the whole thing. I put it up here by the 4. I want it down here, right after I said it. And I'm going to multiply this side by 4, right? So 3 times 9 is 27. Keep the negative out here. 4 times 9 is 36. Plus -4 times 4 is 16. 4 times 9 is 36. -27 and a -16 give me a negative, or sorry, just give me 43 over 36. Those don't need to be negatives. The whole thing is negative and the whole thing is negative, so the whole thing will be negative. So that negative can be here or here or here. Or there's a little bit, usually faster way, 3/4 plus 4/9. -3/4 plus -4/9. Again, we're not going to pay attention to the negative because we know that they both carry a negative and at the end, it will have a negative too. So here, this is called Mr. Smiley. This is what we're doing, okay? We're gonna say, and we always start up here, we're gonna say 3 times 9, and we're gonna put that here. So 3 times 9, like we said, is 27. And then we're gonna go here. 4 times 4. We're gonna use that plus sign. 4 times 4 is 16. Right? And then 4 times 9 is 36. But they're both negative, so we know this is a negative. 27 plus 16 is 43 over 36. So Mr. Smiley might be a faster way to add or subtract fractions, if you like. All right, and that is the end of the second lecture. Thank you very much.